I'm going to switch over a bit to looking at quality versus quantity and how we balance that out. Again, Paula, I'm going to give you this question. I think there's a lot of focus on saving water, but sometimes food industry leaders also need to look at the quality of the water, because in the end, that also determines the quality aspect of our food products. So if you can share a little bit on specific quality aspects and maybe safety aspects that's important for food leaders to know about and to take into account when they start looking at these initiatives to save water.
Okay, thank you, Anza. Thank you, all of you. So we have to consider, in my opinion, two focus. One is the scarcity of water. So we have to understand that the scarcity causes also an increase of contaminants, for example. So we have some low limits, but if we have a scarcity of water, we have higher concentration of some contaminants. And on the other hand, for food, in particular for food site, also we have to think that water is over there, and but inside the food chain. So it is the main component inside this food chain, and on the other end, water transports substances, chemical ones and biological ones. So we add water, food, for example. So if we have a high concentration of some pollutants substances, maybe we can put these substances in our food. But we have to take a lot of information, and so the method is not in the first step to do all the analysis of all contaminants in water, but to produce, in my opinion, a water safety plan that is specific for each site.
Thanks for that, Paula. I think it's a good quick summary on that. Most probably a bit more complex than we have time for today, but thank you for that quick summary. So I'm going to move on to discussing a bit more specific contaminants, and if I say specific contaminants, we talk about PFAS. So you mentioned contaminants, and some of these contaminants are really resistant in the environment, and it's important for food leaders to have a good understanding of how to manage these and how they can actually safely discharge some water if it goes back into the loop. So a question maybe just for the audience is to quickly talk to us on what is PFAS, and if you can have a quick simple explanation maybe on what it is and what is the concern for PFAS in the industry, in the food industry, that is.
Okay, so when we speak about PFAS, we speak about a big group of 1,000 molecules that we have per and polyfluoroalkyl substances, and also define emerging contaminants or also forever chemicals or persistent mobile organic compounds. And we have a short or long chain of carbon atoms with a strong bond between carbon and fluorine. And this is one of the strongest chemical bonds. But it means that therefore, it's the most important bond, the strongest bond, and then it means that it's difficult to destroy and to transport these kind of molecules. These kind of molecules are synthetic man-made substances and are used in many of consumer goods, like as sticking pans or firefighting foam or film. So PFAS are everywhere in our consumer goods, and they are inside our food chain. So they are in contact, for example, with water, but with soil, with air, with ambient air, and also with food. So if I have a packaging with some films of PFAS, maybe PFAS can go in food. Okay, so it's very important to understand that all of this is inside the food chain, and we have to try to find what is the sources.
I think the next question relates a little bit to expertise. I know there's specific capabilities that our teams in Italy has developed to both detect PFAS, but on specific matrices, but also to look at root cause. And maybe you can speak a little bit towards the expertise, but also to maybe give a bit of direction to food safety leaders specifically on how to mitigate PFAS and to deploy specific actions to mitigate the PFAS risk. So it's a combined bit of a question, but if you can look at expertise basically and how can you support industry leaders to mitigate risk?
Okay, here in Italy, we have been working for 10 years, in particular from in PFAS, in particularly in water, and also so we develop the method for water and then also in food matrices and in waste also, and now we are building a method for stack emission, and we have different approaches, and we are online with the new information that we have all around the world, because you know that PFAS are 1,000 molecules, but we have no the standard of all the molecules, and a lot of these molecules are not we have not enough knowledge about the molecules. So we can analyze targeted compounds, because we have a law, we have a list of molecules and a list of compounds. But on the other hand, the world is moving also in an index of PFAS that is a generic index that is AOF, for example, in water. And it means that we can analyze only the fluorine that come from organic compounds, but we have a lot of fluorine. But I think it means that if I find fluorine, total fluorine, maybe inside I have some molecules of PFAS. And then there is another method that is untargeted analysis, because in thousands of molecules, we need to try to find with our sophisticated equipment suspect molecules through a library in the equipment. And so our experts are studying, going on every day in this topic.
Great.
Of course, Hamza, as Paola said, we've developed those capabilities in Italy. But now, as you know better than I do, Hamza, we also have those capabilities ready for our customers in North America.
Thank you for bringing that up, Nicola. And I think also as we stay close to the regulatory framework and continuously change market, I mean, yeah, thanks for bringing that. It's important point to highlight.